All right, guys. I'm going to do the first three problems from section 10.7 for you. These can be a little tricky, but I think if I do these for you, you'll be okay as far as doing these for yourself. So problem number 1, all right, states, what is the area of a circle with a diameter of 16 inches? Leave your answers in terms of pi. All right, so we got a diameter which is equal to 16. Now remember, area of a circle is equal to pi r squared. Do not get confused. All right, there is a difference between area of a circle and circumference. So the area of a circle is pi r squared. All right, circumference is 2 pi r. All right, so let's figure this out. They tell us, all right, that the diameter is 16. That means the radius, all right, is half of 16, which would be 8. If we square that, our final answer is 64 pi. All right, and you can leave it in terms of pi, which is great. So let's move on to a couple of the trickier ones. Number 2, all right, they give us a circle and they ask us to find the area of the shaded region. All right, well, the shaded region is all in here. All right, and they tell us that the radius is 9, and this central angle right there, all right, that is 75 degrees, which means this arc is 75 degrees. All right, so we actually have enough information here to do this. So we have a central angle of 75, and the arc is 75. Now, when they ask you, this is called, this shaded region is called a sector of a circle. I like to think about it as a slice of pizza. All right, this is a slice of pizza. Now, if you looked at the photo that I put on there, a segment of a circle, all right, would just be like the pizza crust. We'll get to that in a second. So let's solve for the area of this sector, all right? So according to our area of a sector, we take the measure of the arc, all right? The measure of whatever the arc is, which is right here, all right? We divide it by 360 degrees, all right? We divide it by 360 degrees. We multiply by pi r squared, all right, which is the area of the whole circle. So the measure of the arc, once again, this is measurement, not length. So the measure of the arc is 75 over 360, and we multiply this by pi, the radius is 9, squared. So what I like to do, all of this is in the numerator, okay? What I like to do is multiply the 75 by 81, all right? So in our numerator, all right, and I have my calculator here, so 75 times 81 is equal to 6,075. So I have 6,075 all over 360, and don't forget about that pi, and I'm going to leave that up there. Now remember, with your calculator, you can actually reduce a fraction, all right? I typed in the fraction, 6,075 over 360, and once again, you could reduce it before. This is just how I do it. You push the math button right here. See frac, I push enter, enter. So I have now reduced that fraction to 135 over 8. So my final answer is 135 over 8. Don't forget about that pi. And that is your final answer. Because they asked us to leave it in terms of pi. So that's how you find a sector of a circle. Let's find a segment, okay? Let me move my sheet of paper up. So, problem number 3. Now, once again, these can get kind of messy, so try to follow along. We have our circle that they give us, and we've marked off this area. I should have grabbed 2 pens. If you connect these 2 points, all right, this shaded region here, that is the segment. It's almost like the crust of the pizza slice that we had up here. If I were to draw it up here, I would connect these, and then all of this in here would be the segment, right? So for here, they want us to find this. So guess what we have to do? We need to find the area of the sector, all right, and then subtract the area of this triangle right here, okay? So they tell us that this is 2. They tell us that this here is 120 degrees, which means our central angle is 120. Now, well, I'll get to that later. So when we're solving for the area of the segment, the segment, we need to take area of sector minus, all right, minus area of triangle. And that'll equal the segment. Okay, area of segment. So, finding the area of the sector, we just did it. We take 120 divided by 360 multiplied by pi r squared, or pi, our r in this case is 2, they gave it to us, all right? And we subtract the area of the triangle, okay? Well, what the heck is the area of the triangle? Well, we don't know that right now. So, in order to figure that out, notice what I do. Remember, that central angle is 120 degrees. I'm cutting that in half. Look at what we have now. A 30, 60, 90 triangle. All right? And if our hypotenuse of a 30, 60, 90 is 2, that means the shorter leg is half of that, which is 1. All right? And then the longer leg is 1 times the square root of 3. All right? Or just square root of 3. So, to figure out the area of this triangle, base 1/2 base times height, right? Look at that. Our height is 1. Our base is the square root of 3 times 2, or 2 root 3. So, the area of our triangle, 1/2. The base is 2 times the square root of 3. The height is 1. All right? So, let's reduce this. We have 120 times 4. Remember, it's 2 squared times 4. We divide by 360, and I'm going to reduce that fraction. That's 4/3. All right? So 480 divided by 360. Let me do that again. 480 divided by 360. All right? Push the math button. Frac. 4/3. So this is equal to 4/3 pi, and we are subtracting off, well, 1/2 times 2, those cancel. What are we left with? 1 times the square root of 3 times 1, which is just square root of 3. That is your answer for the area of a segment of a circle. So the answers can be kind of messy. Definitely do this homework, all right? You will have a quiz on this tomorrow, all right? Short quiz just like we did before, all right? Hopefully everybody's healthy. See you later.